This time we're going to be talking about some of the different kinds of operations that you can do with radicals. So let's get started. First, we're going to review a couple of the problems that we learned on our last lesson, and that's just how to simplify a radical. So if we try to simplify a radical, let's take a look at how that would work. So first of all, we got the square root of 45, which is not a perfect square, but we can break that down into 5 times 9. And then 9 breaks down further into 3 times 3. And we notice that we have a pair of those, so we can take one of those 3's out of the square root symbol that was still in there. If you kind of use your imagination, it comes out front, and the 5 is left inside the radical, and so there's our first simplified radical. Our second one, we can break that down into 10 times 10. And right away we can see that that's already a pair, so that's a perfect square, so we can pull that out of the radical without going much further. But what about the y's? We actually have 3 of those. So what I'm trying to point out is I could break this 10 and this 10 down into 2 times 5 and 2 times 5, but I can already see I have a pair here, which if I bring one of them out, will take care of this square root. So I can bring a 10 out of the radical, and I can bring one of these y's out of the radical, and that leaves me with just one little y left inside the radical. So now that one is simplified. Now on this last one, there's actually a number out in front of the radical, so when we start pulling things out, we're going to have to multiply whatever we pull out by that number. So let's not forget to do that. So 128, sometimes I like to just divide it in half if it's an even number. So that would be 2 times 64. And then I happen to know that 64, oh my goodness, that's a nice one. That just breaks down into 8 times 8. So there's a pair right there. So I've got this so far, and I know that the 8 times the 8 is a perfect squared pair. Now I could break that down into a bunch of 2's, but no need to go that far when I already know I have a perfect square right there. So I'll take that out front, and I will have -4 times one of those 8's, and I'll have 2 left inside the radical. But what about the w's? Now remember on our last lesson we said if you have an even number of exponents, all you have to do is divide that number in half to take the square root. So you can bring a w to the squared out front, and you will have -4 times 8, which is -32. And then this will break down into, like I said, you break it in half, w to the second times w to the second. You take out one of those w to the seconds out front, and you are left with just another square root of 2 inside the radical sign. So that's what we've been doing, or that's what we were doing on our last assignment. Okay, so today we're going to talk about adding and subtracting radicals. And to be able to add or subtract radicals, the radicals have to be the same. They have to be like terms, just kind of like the exponents we just finished doing it with our scientific notation and other things. Okay, so take a look at this little problem down here at the bottom. We got 5 times the square root of 6 minus 3 times the square root of 6 plus the square root of 6. You notice we have a lot of square roots of 6 there. So in order to combine those together, all I have to do is add the coefficients or subtract 5 minus 3 plus 1. And when I do that, I end up with 3. And then I multiply all of that by the square root of 6. So that particular problem would simplify to be 3 times the square root of 6. Here's another one. We've got 3 times the square root of 2 plus 8 times the square root of 2. Well, since they're both being multiplied by the square root of 2, we can just add these 2 together. So 3 plus 8 is 11. So we actually have 11 being multiplied by the square root of 2 here. Here's yet another one. On this particular problem, we actually have negative 6 times the square root of 5 and 8 times the square root of 5 on either side of this particular problem. So we're going to combine the negative 6 and the 8 together, and that will give us 2 square roots of 5. Meanwhile, you've got 3 times the square root of 3 left over, and so it will just tag along for the ride because we can't simplify it any further than we already have. All right, but if the radicals are not the same, see if you can make them the same. And so I needed to put a little m right there instead of n. But you're trying to make them the same, and then if you can make them the same, you can combine them. So what do we mean by that? So let's take a look. So you see that 8 right there? We want to know if we can do something to simplify that so it will become a 2. So let's break it down. We've got 2 times 4, 2 times 2 times 2. And then we have negative 2 out front. Keep in mind that radical sign is coming down until we can do something else with it. So we circle one of those pairs of 2's inside that radical sign, remove it out. It's like taking the square root of this 2 squared. So we'll have negative 2 times the square root of 2, or times 2 with the square root of 2 left inside. So we've got this written in terms of a square root of 2 inside, minus 3 times the square root of 2 when we bring this down. So then this first one will simplify to be negative 4 square root of 2 minus 3 square root of 2. And negative 4 subtract 3 is equal to negative 7 times the square root of 2. So that's how you would do one if it needs to be simplified a little bit before you can get some like terms there, or like radicals, okay? All right, so let's try yet another one. Here's 3 times the square root of 45 minus 3 times the square root of 20. So both of those can be simplified. So when we simplify them, we're hoping that we'll get something that can be combined together. So this one happens to be 9 times 5, and that breaks down into 3 times 3 times 5. Meanwhile, this last one breaks down into 4 times 5. And then that can go a little bit further and become 2 times 2 times 5. So when we combine all of these together on this first one, we're going to end up, we got the radical here. We're going to take out one of those 3's, and it's going to go out in front and be multiplied by this 3. So we'll bring this 3 down here, and we'll have 3 times the square root of 5. Because one of those 3's came out. And then we're going to have minus 3 times 2, because one of these 2's is going to come out of the radical sign and be out front. And then what's going to be left over is just a 5 inside. All right, so 3 times 3 is 9. So 9 square roots of 5 minus 6 square roots of 5. What is 9 minus 6? Well, that happens to be 3 square roots of 5. So there you go. Hey, this is not looking too bad. So this does look very simple compared to what we started with, right? Okay, so here's a couple more. So we've got 3 terms here, so you just got to get pretty efficient at breaking these down. So 12 would break down into 2 times 6, or 2 times 2 times 3. And so you got that with a 2 out front. Sorry, this is a 2 right here. Then we've got minus. This 8 is going to break down into 2 times 2 times 2 times 2. I happen to know that's what that breaks down into. So we'll have the radical 2 times 2 times 2. And then the last one's going to break down into 2 times 9, which in turn breaks down into 2 times 3 times 3. So let's circle the pairs that are under the radicals. We got 3's here, got 2 2's here, and we got 2 2's here. So if we take one of those out, we end up with 2 times 2 square roots of 3 minus 2 times the square root of 2 minus the 3 times the square root of 2. And so then we end up with 4 square root of 3. And then we have minus 2 and minus 3 square root of 2. So that's going to be minus 5 square roots of 2. So that's going to be our simplified version of that particular problem. Okay, so you would, if you have one that's got 3 parts, that's what you'll do. We'll skip over this one because it's very similar to this one. Just remember, if it has a number out front, like this one did in the first one, you have to multiply whatever you bring out of the radical by the number that's already out in front. All right, so we're going to do the worksheet operations with radicals. Good luck and thank you very much.